Okay, folks, we definitely want to finish up our conversation about the chemical properties of transition metals, the color and magnetism, and a little bit about chemical reactivity within groups. So, most main group ionic compounds, as we already know, are colorless and diamagnetic because the metal ion has no unpaired electrons. So when we go ahead and we see those different ions, so for example, like sodium Na+, we know that this is actually equal to the neon electron configuration. So we definitely do not see any type of coloring because all the electrons in these orbitals are paired up. But with many transition metals, the ionic compounds are highly colored and highly paramagnetic because, again, the metal ion has one or more unpaired electrons. So when we look at these compounds that are like blue, yellows, reds, greens, pinkish, etc., these all have unpaired electron in their d orbitals. Okay? And these unpaired electrons allows for magnetism, and so that means it allows for more bonds. And so when you have those unpaired electrons, it also means that you can exhibit color. If you have something that's diamagnetic, where all the electrons are filled in the d orbitals, as we see here, all 10 electrons are filled, and it's diamagnetic, then that's going to be a situation where you see things or compounds that are going to be colored. Maybe not that. Now, one thing that we have to always talk about, like we spoke about before, is it all depends on oxidation state. With transition metals, many colors can arise from the same element. So, for example, our titanium, we do see a white amount or white color here, but we know that color can be purple depending on the oxidation state of titanium. Right, folks? We will learn a lot more about crystal field theory, which helps us understand how color and magnetism are created. Crystal field theory is basically going to allow us to understand how the d orbitals split, allowing for the different colors of magnetism to exist. Okay, folks? So as we go along, we'll get more details about this theory, okay? And finally, I want to end with chemical behavior within a group with a focus on ionization energy, as we saw before. So ionization energy values are going to generally increase down the transition group. So again, we're starting from the groups here. We have our 3, 4, and 5, okay, or sorry, 4, 5, and 6. And if you go down a group, we normally are going to see that we're going to increase our ionization energy, basically as the elements get heavier, okay? But this also means that reactivity is going to decrease down that group. So what potential effects can this have? Well, let's see, for example. Say we're going to be talking about this group here and this group here, and we know that reactivity is going to, of course, decrease down the group. So our tungsten here and our Re, as you can see, they can have similar reactivity. Now, because of that, when you're thinking about all the ways that we can kind of extract metals and stuff like that, when different transition metals have the same reactivity, it's going to be harder to process them and extract them or really separate them to get those pure compounds. So sometimes that could be more money for more processing just to get exactly what you need, okay? And of course, just like the first ionization energy, you can use other things like electronegativity, which helps us understand metallic behavior, like we saw before, to just connect those physical properties with that chemical behavior that potentially can happen with all the different differences in these transition metals, okay? So we have went through so much learning about our model transition metals, right? And this whole entire chemical runway. So you just want to make sure that you're taking the time to process and focus on your flashcards and necessary examples, and then want to make sure that you're making as much connection as possible to what the transition metal properties are, from atomic to physical to chemical, and then connect them all together. Next, we're going to focus about learning about other compounds these model transition elements can form and new theories to help us understand properties of these transition metals in more detail. All right, folks? So I'll see you in the next part.